problems that you can foresee with it. What would happen if I asked you for more changes? Does your code feel brittle or flexible, simple or complicated? After this reflection, we'll start to get more serious, and we'll talk about solutions. I'll reveal how I organize my code for the project, and we'll start moving towards becoming professionals in our code organizational techniques.
Yeah, this one is a little bit hard. Let's make it the middle version. And how do you feel about the code? Like mess. Really don't like it. It's all things mixed together. How many clicks you have clicked your cat? Like I don't know, 100 times. Something answer.
If the previous exercises were difficult for you, it might be because the code organization isn't ideal. Now, that's nothing to be ashamed of. Up until now, you've learned HTML, CSS, and JavaScript. And you've learned some pretty advanced features of JavaScript too. But one thing you may not have learned about is code organization.
Yep. We're going to start to organize our code, make it more easier and clear.
Hey, Andy, so how'd it go this time?
Pretty terribly. It probably took about 10 times longer to get 5 cats working than it did for 2, which doesn't make a lot of sense.
So that's rough.
Yeah. I had a lot of divs. Is that a good thing? A lot of divs with cats and buttons and, cat 1, cat 2, cat 3. And I tried to, in the JavaScript file, iterate over all of those and bind the buttons to the counters for the different cats. But everything kept getting down to the very last cat.
That was that closure.
It was. That was where the 10x time increase came from, was figuring that out. But, it's working, so it's good. But I don't want to keep making things this way.
Story time. This reminds me of when I first started building things with wood. So I went down to Home Depot, I bought some wood, I bought a hammer and a box of nails, and suddenly I could build things. And I went crazy with it. I built all kinds of small things, occasionally hitting my finger. But generally I was successful. Eventually though, hammers and nails didn't quite cut it. So I saved up some money and I upgraded. I bought a screw gun and some screws. I bought a chop saw. I even bought some of these. And I built all kinds of cool things with these tools. And the things I built were much better because my tools were better. Then I wanted to build an actual structure, like something I could stand on. And guess what? I didn't trust my own designs. I knew that if I took my methods from all those small projects and scaled them up, I'd build something that wouldn't hold my weight, which would be bad. Now, I didn't need to go out and buy new tools. I had everything I needed, everything physical at least. What I did need was some organizational guidance and some new building techniques. So I spent some time experimenting. I discovered that if I separated out my sections of my project into different pieces that attached to each other, it'd be easier to build, potentially more stable, and much easier to change later. Then eventually I Googled around and I got even better techniques that way. Things that would have taken me a long time to figure out on my own. Now this is exactly where you are right now. You have great tools. You know JavaScript. You know the features of the language. But you do need to learn better organizational techniques so your applications are stable and bug-free, cleanly written, they scale well, and are extensible. Spaghetti code is easily avoidable once you know how to avoid it. First, though, let's talk about the problem. Things get really messy when you connect things together. And an application is ultimately all about connecting pieces of code to each other. But if you connect all the pieces to all the other pieces, suddenly you can't move anything around anymore. Now, you may have noticed that I'm not at my desk. I don't have my computer, everything's white. It's actually a little weird. That's because we're in concept land. And the whole point of concept land is to not think about code. So, sit back, relax, and let's just talk in concepts and metaphors for a moment. Here's a metaphor. Let's go back in time to the invention of the telephone. See, when there were only two telephones, things were pretty simple. The phones could connect directly to each other, and then we're done. Two telephones means one connection. Now let's add another. Now we have three phones, and each phone still needs to connect to every other phone. That means three connections. Let's add another one. Now we have four phones, and each phone still needs to connect every other phone. That's 4 phones and 6 connections. Now this is a pretty shape here, but it's not very good if you have a bunch of wires all over the place. Let's add several more. With 10 phones, we have a lot more connections. 45 connections, in fact. I'll tell you, this took me a while to draw. So you can imagine what 11 phones, or 15 phones, or 20 phones, or 2,000 phones would be like. So here's a table of what we've learned so far. As it turns out, the number of connections is ultimately defined by the equation n times n minus 1 all over 2, where n is the number of phones. Now, if you're a math geek, this is related to n times n plus 1 over 2, but in this case, n is 1 less than the number of phones. So I've simplified this equation here. So now that we know that, how many connections would a small town with a population of 2,000 have? That would be 1,999,000 connections. I'm not going to draw this one for you. So how do we build this in reality? I'm sure you probably have a better solution in your head already. Let's make every phone connect to a hub. Now how many connections do we need? Well, if you think about it, for every phone you have, it connects to one thing, rather than n number of things. Let's take a look at our chart again. If we have 2 phones, our number of connections will be 2. If we have 3 phones, our number of connections will be 3. 4 phones will be 4, 10 will be 10, and 2,000 will be 2,000. As you can see, with 2 and with 3 phones, we end up actually doing better off, or the same, with our original direct connection method. But generally speaking, this shows you that connections are complexity. If you saw these two things on a graph, this one would go kind of like that. This one would linearly increase. So now we know that we should minimize our connections. It turns out software development is very similar. So let's take a look at that. Let's get back to the real world now. Now that we've talked about separating things out, let's talk about what separation of concern specifically means for writing applications. We can separate our code into a few fundamentally different pieces. In this course, we'll refer to them as M, V, and O, model, view, and octopus. Octopus, you ask? Yes, we have Larry the octopus to help us out. Now let me tell you a little bit about Larry. Now, Larry really dislikes disorganized code. Actually, Larry hates disorganized code so much that Larry has decided to do something about it. Larry separates our concerns. Now, what does that actually mean? Well, no matter what the size of the application, programmers like to organize everything in a few buckets. Let's talk about them one by one. First, the view. This is all the stuff the user sees and interacts with. That includes DOM elements, input elements, buttons, and images. Basically, this is the user's interface to your application, both for giving your application data and for reading data. Now, speaking of data, here in the model, this is where all of the data is stored. That includes data from the server and from the user. Now, the model and the view are connected, specifically by our octopus. Our octopus is what provides the separation of concerns that we so desperately need when we're building applications. Now, you can think of the octopus as the thing that holds things together, but also keeps them separate enough to allow changes in individual pieces without upsetting the rest. In other words, I can change my view here without disturbing my model. Or I can change the way I'm storing my data without disturbing my view over here. If you search around the web, you'll find all kinds of acronyms, like MVC, MVVM, MVP, and MV asterisk. These stand for Model View Controller, Model View View Model, Model View Presenter, or Model View whatever. Fundamentally, the C, VM, P, and asterisk are all solving the same problem, separating our model from our view. Now you'll see all kinds of discussions online about how different these all are from each other and in what ways. But all of those discussions are assuming you already know that they're basically the same thing. So we'll worry about the differences later, and for now, we'll consider these all versions the same thing, and we will name them octopus.
Right, so in here it's talking about the way we organize our code. Like it's going to separate the model and the view, and with maybe a controller or or the presenter or something like that. So in the view, we're going to have what users can see, like those DOM elements, like your HTML file, like the way we DOM create element. Those are the view things user can see on the screen. And also we have our model, which are just those cat data, like a cat image, a cat those cat objects, those cat image, cat name, and how many clicks. Those are the model. And the controller, or say the presenter, the part is for the functions, like to help you to connect the model and the view, also separate the model and the view. And whenever when you need to load something from for example, when I need to load Andy's picture, I'm going to get in the Andy's information from the model, and the controller is going to help me to move those information onto the view, onto the screen, the users can see. And then when I click another button, the controller knows, okay, you're asking for the Bob's image, Bob's name and Bob's information. So I'm going to go to the model, go to M model to grab the Bob's information, and then to move that to the view. So that's a way we use to organize, like the most common way we use to organize our code, right? So right now, I think we're going to using that way to reorganize our code. Let's firstly take a look of the script here.
Let's say I want to build a calendar app, kind of like Google Calendar. Which of these parts of the application do you think would be considered part of the model? The array of calendar events in the application, the buttons for day, week, and month, or the render function for the calendar area?
So it's asking which of the following parts of the model, as we said, like if the thing user can see, that is in the view. And if it's a function that can do something for you, it's not going to be in the view. It's going to be in the all cumulus or in the say in the controller. And if that's just somewhere store the data, like the cat data, like or the calendar data, then that's as model. So in here we have three options. The first one is the array of calendar events in the application. The button for day, week, and month. And third one is a render function for the calendar area. So let's take a look at reverse way. So one, the render function for the calendar area. The render function, what the render function is supposed to do. Imagine like a render is basically it's going to show the layout for you. It's going to do something. Like when you load the page, it's going to render something on your screen. So it's basically doing some function for you, and the user cannot see the render function. They can see the calendar, yes, but they cannot see the render function. So it's basically should be in the controller part. It's not the view, not the model, just but the controller part. And the button for day, week, and month. The button is something user can see. It's just a button that user can click and can do anything they want. So this should be in the view part. The button is something showing on the screen, so it should be in the view part. And there's an array of calendar events in the application. It's array of calendar. So basically, it's an array of some data. That is something user cannot directly see. The controller is going to show those data in the calendar, but the user cannot really see that array of code or array of data. So that's basically that array of data is a thing in the model. That's something that we need to separate from the view, and also going to connect it to the view. Right? So it's just an array of data. So any kind of data in JavsScript file, they are going to be the model. Right? So the correct answer should be A here, the first one. Submit the answer here. Why Daniel allows me to do submit the answer? Right. So exactly, the array of calendar events is part of the data for the application, and so it is stored in the model.
The array of calendar events is where the data is stored, so it's part of the model. The other two, the button and the render function, both belong to the view, since they're responsible for what the user actually sees in JavaScript. Let's say I wanted to build a YouTube playlist app. It would let a user type in URLs and play the videos one by one from this playlist for the user. Which parts of these applications would be considered part of the view?
Right, it's talking about so what should be the view part. let's say the four options here. The first one is an input element. The input element is where the user can type stuff, right? Like an input element when they type some stuff. It should be part of the view, right? It's a place that the user can see it and can touch it. So it's gonna be in the view. So we're gonna select the first one. And for the second one, the array of URLs to play. The array of URLs again is data. It's array, and it has a little bit different URLs inside it. So it's not gonna be visible for the user. It's just some data. So it's gonna be in the model. And the function that adds a URL to this, again, it's a function, so it should be in the view. And the area where a video plays, like this should be a view, right? The video is available for the user. User can see that video. So the area where a video plays should be a view part. Right, let's go to the next one.
Let's go through these one by one. The input is part of the view because the user uses it to interact with the application. The video playing area is also part of the view because it's what the user sees. The array is not part of the view, it's part of the model, which is the data that the application is using. And our function here is part of the octopus. That's what ties the model and the view together. The view calls this function when a user types in a URL here and presses enter. And the function adds a URL to the model, or data. Remember, the octopus's job is to connect the model and the view together.
All right, let's keep going.
Now that we have the concepts down, let's go through some actual code. You can find a link to the repository that contains this application in the instructor notes. So here we have a pizza ordering application. You can click on this Add Pizza button here to add pizzas, and each pizza has its own unique number. You can also click any of these X buttons to remove the pizza. And you'll notice that if we add a couple more pizzas, it starts off where we left off, 7, 8. Now let's take a look at the actual code behind this, more specifically, the model that's driving it. And before we dive into the JavaScript, I'll just mention that we have an HTML file here, and we've also got a style.css file right here. You can go through this code on your phone if you'd like to figure out how it works, but it's relatively simple. Just some HTML DOM nodes and some CSS selectors and properties. The JavaScript is where the heart of this application lies. We have var data, and if we scroll down, we also have var octopus and var view. Let's take a look at the model here. Now in this application, the model is just called data. It doesn't necessarily have to be called model per se, but that's its function. And you can see that our model is just a simple object with a couple properties inside. It's got a property for the last ID of the pizza and an array of pizza objects. With such a simple example, it may not seem obvious why we want to separate this out, but bear with me. Sometimes our model isn't so simple, and we'll see examples of this in the near future. The view is a bit more complicated than the model in this application. It's an object, as you can see by this open bracket right here, and it has two methods, init and render. We call init to get things set up, and we call render to update our view. Now, the HTML is also part of the view, so I've opened up index.html. You can see we have a button here and an unordered list for all of our pizzas. There's also this script template down here, which is just a fancy word for some HTML that we're going to use again and again when we make the pizza object. Let's hop back into our app.js. First, let's go over our init function here. Now, for the moment, I'll ask you not to get too mired in the details. We're really looking at the overarching organization of the application, okay? So simplified and glossing over details, we're doing the following. First, we're adding an event listener for the button which runs the add pizza function. Then we're grabbing some things from the DOM and we're storing them to variables so that way we can use them in our next step. Then we're adding a click listener for the pizza list. And if we're clicking on a remove pizza button, we're running the function that figures out what we clicked on, and then ultimately calls the remove pizza function. And lastly, we're telling the view to render itself. So speaking of rendering itself, what does that render function very smart or optimized, but it works just fine. So, clearing the pizza list, and here, getting the visible pizzas from our octopus, which we'll talk about later, and for each one of those pizzas, doing the following. Filling in the template HTML with the pizza ID, and then adding it to the pizza list in the DOM. So this view here is not particularly smart, but it is separated out, and that's what's most important. All of our view logic is in one place, rather than scattered throughout our entire application. We'll see the ramifications of this in the next node.
Right, so he's just basically talking about how should separate your function, and separate the view function belongs to the view part, separate the model function, like the model is basically just data, and you also have the controller functions to which you can connect two things, and to grab the data from the model and give them to the render function or to the like a clear function and make them available for the views. All right, so let's keep going.
The view, but you also may have noticed the octopus object floating around. Now, what the heck is it doing? Well, as we discussed before, the octopus is what is tying our model and our view together. Now, you may have noticed that the model and the view both never directly talk to each other, and that's by design. Our octopus is the only thing that connects them. I like to imagine the octopus as a sort of buffer, connecting the view and the model, but also letting them move more independently than if they were wired directly together. That means you can change how your app looks without messing up your model code, and vice versa. So the octopus is doing things to help out our view and to help out our model. Let's go through those things. Our add pizza function gets called by the view and adds a pizza to the model. And lastly, tells the view to update itself. Our remove pizza function is also called by the view whenever you click on one of the little X's. It figures out what pizza was clicked, and it sets the clicked pizza's visibility to false. And once again, it calls view.render. You may notice these are the only two places that our data object, our model, gets mutated or changed. Once again, the view never changes the model directly, only the octopus. Now we've got two more functions to go. Get visible pizzas is a function. It's almost like a tunnel that the view uses to get the data from the model. So rather than the view saying, hey model, what pizzas do we have? The model asks the octopus, and the octopus goes and gets the pizzas. Now, why doesn't the view just do it directly? Well, there are two reasons. First of all, as we discussed before, it's very important to separate out your view and your model. If you don't, you end up with some pretty nasty code as your project gets bigger. But the second reason is that this get visible pieces function doesn't just return the pieces directly to the view, it actually filters them for us. It takes all the pieces from the model and it filters them. And it only returns any pizzas where pizza.visible is true. So if we go back over here to our application and you add a whole bunch of pizzas, and then you remove a bunch of them, the way the application works is that 1, 2, 7, 16, and 17 in this case, these all exist in the model, but so do all of the other pieces we ever made. That get visible pizzas function in the middle on the octopus is taking all of the pizzas and only giving the visible ones to our view. And lastly, we have our octopus.init. When you call that, it does all the necessary things to get our application up and running. In this case, the only thing it has to do is tell the view to initialize itself. So once again, big picture, if you have your model and your view, your octopus is the thing that connects them to each other. They never talk directly. So all of these functions are different ways of getting between the model and the view. Now it's your turn. Let's move on to another more real-world example. Now this right here is a groundbreaking new application called Udacity Retain. Aside from a snazzy name, it does have some pretty good organization when you look at the underlying code. So let's do just that. We have an HTML file, a CSS file, and a JavaScript file. If you look at the JavaScript file, we see a pretty similar organization in this app as we saw in our pizza application. Now we just spent some time going over the pizza application together just a moment ago. So go ahead and clone this repo and get it onto your local machine. Then take a look at it and try to figure out roughly how it's organized. You will see some similarities between the pizza app and this app here. Now, if you have a moment of disorientation, that's normal. Anytime I look at someone else's code for the first time, it takes me a bit to get my bearings. So don't worry if it takes you a few minutes to start understanding things. Feel free to comment things out and see what breaks. Add comments as you figure out what things do and notice the big picture. Does the model ever talk to the view directly? How about the view to the model?
All right. So this one we find the repository here. So here is the code they have. They have an index.html, have a JavaScript folder for the JavaScript code, and have a CSS folder for CSS code. Let's just take a look at the index.html first. So it's really simple. It's basically like mostly empty. It just have a head with a meta tag, title, and a link to the CSS style. It has a form. Have a form with a input ID equal to something, class equal to something, and a list. And two script tag. One is using the jQuery. Another one is just a JavaScript file they created. Let's take a look at the JavaScript code. So here is the JavaScript code. It's pretty long. They already separate these things for us very clear. They have the model, they have the octopus, and also have the view. So as we can imagine, the view ones is basically have some initial data for the stuff, and have a render function. Every time when we do something, we need to call the render function to re-render stuff. And they have their model here. The model here, they're using the local storage. They use the local storage here to getting the initial data from local storage. And they also have the add function, which adding the new stuff to local storage. It's like our bookmark. Like it's going to have a data, and it's keep pushing the things into the data and send it back to the local storage. And have the get all nodes. Let's just getting everything from the local storage. And the functions they have, those are the functions from the controller from the octopus. It has a every time when you're trying to add some new nodes, it's going to call the function model, call the model variable, and call add function to add stuff into the model, and then call the render function. So the render function has nothing to do with add, but every time when you're trying to add something, you're gonna call this add new node function in the octopus, and this octopus function going to call both of them, connect them together, and it's going to both adding the stuff to the local storage by calling the add function in the model, and it also call the render function in the view, which is gonna re-render the page. It's gonna add in the list item into the list. And also the other function is called get nodes. It's not like whenever when you render something, I think it's going to try to get all the nodes, and it's not going to directly get the nodes from the local storage, but it's going to call the function in the model. The model is going to handle all the data you will have. Right? Same thing for the initial and function. It's just gonna call the function we have in the model and the view to separate things into different parts. Right? This is how you organize your code into model, octopus, and the view. Right? View is handling the layout the user can see. The model is handling the data behind the app, and the octopus is connecting them together or separate them into two things. So that's it for this project. We can just keep going to the next one.
Now we're going to implement a new feature. The new feature is super simple. Right now the notes go in chronological order from past to present. We want them in the reverse order, so the latest note appears first in the list. Where should we make this change? Does this belong in the model, the view, or the octopus?
So they want change this one to reverse the order of the nodes. The correct answer should be octopus. Oops.
The change goes in the...
Yeah, they're gonna explain this.
Now we're going to implement a new feature. The new feature...
What? I just submit the answer and show the answer.
Now we're going to implement a...
So create, submit answer.
The change goes in the octopus for a few reasons. First off, we don't want to mess up the data that we already have. And second of all, we don't actually need to change the data itself. It's just the way we're getting the data from the model to the view. Now, why not the view? Why not put this in the view? Well, first of all, the view shouldn't pull things directly from the model. Remember, they shouldn't talk directly. So as long as we're going through the octopus, it makes sense to give the view only what it needs. Now that being said, technically you could put this functionality in the view, but for my model view octopus example, I'm going to leave it in the octopus. The octopus is where I want all of the real smarts to live in this organizational paradigm, whereas the model and the view themselves are relatively simple. Now, if you use other organizational libraries, they all have different opinions about where exactly different functionalities live. But in all of those cases, they're consistent and well thought out. So for MVO, we're going to keep all of the smart functionality and the filtering and everything in the octopus.
Right. So it is basically saying, remember, like our data is of those items, and it's just going to because we're not just basically we're not going to change the data we stored there. It's just we want to reverse the order of it. So technically we can put that in the view, but because of we are going to following the MVO structure, so we're not going to directly communicate between there's no any direct communication between the view and the model. So the view doesn't really care about that. It only cares about just you give me some data and just show them. And the way we communicate them is using the function in the octopus. In octopus, we basically have for loops here. Like it's going to get the data one by one from the model and show them one by one on the screen. And we just can basically change this for loop. Instead of from the first one to the last one, just change the order of the loop, getting from the last one to the first one. And that's going to be in the octopus. That's going to be a place where we connect the view and the model, and it depends. It's going to tell it's just going to we'll just change the function over there, so it knows like we can change the way you give data, change the order you give the data to the view from the model. Right? Let's keep going.
I'm going to show you where I put my code. Over here in the octopus, in get notes, instead of returning model.getAllNotes, I'm going to instead return model.getAllNotes.reverse. So my octopus, when it passes all of my notes over to my view, it actually reverses it for the view. The view doesn't have to worry about it. Now, I would like you to try to implement another feature. We're going to add a date to every new note that we create. And we're going to display that date too. Now let's just talk generally about how we're going to do that, and then I'll set you off to do it yourself. So first of all, we're going to need to store some kind of date when we make a new note. Now I'm going to open up the console, because one great way to do this would be using date.now. When you run date.now, it returns a big number which represents this current moment in time. If I run it again, you'll see that the number has gotten a little bit bigger. So if that's how we store our date, we're going to need to put that inside of our add new note function. That's where it creates the object literal, which becomes our note. So now we're not just storing content, we're going to store a date. So that changes our code so that way it's storing a date every time we add a new note. We don't need to change the getNotes function because it just returns all of our notes, including their content and their date, and it reverses them for the view. And speaking of the view, that actually needs to change as well. Now that we're storing dates for our notes, we probably want to display that date as well. Now you can add that in the HTML string down here that we're generating. I suggest putting it in an element with a class of note-date, so that with the CSS that I included, it's applied properly. Now one last thing, before when we were experimenting with this, we were creating notes that didn't have dates applied. So if you go back into your console here and you run local storage.clear, it'll wipe away all of the persistent storage. So when we press refresh, we don't have any notes anymore. And all of our notes will then have that date property that you're adding. And now I leave it to you. Go forth and add date stamps to your notes.
Let's see, let me see it. Right, we're gonna skip this one because they are using the jQuery syntax. I don't want to mix you up right now. If you have time, you can do it by yourself. It should be very easy. Instead of only store the content, we're gonna store the object, including the content and the date. Right? We're already done the similar thing in our bookmark. In our bookmark, we basically store things in pairs. We store the sorry, we store the name and the URL, and it's combined together. It's a bookmark. Now this one is just using the jQuery syntax. I don't want you to mix up with that. So let's just directly skip this one and go to the next one.
In future lessons, you can always come back to the examples we went over here and use them as inspiration or guidance. I'm really excited about this next lesson. Coming up, we will be implementing separation of concerns for cat clustering, doing it right. You'll experience the differences between your previous spaghetti code implementation and our new well-organized implementation. It'll feel really good. So let's do it. I'll see you in the next lesson.
Right, so we're going to lesson 2. Lesson 2 is basically we're just going to use what we just learned, MVO, and apply that on our cat clicker.
Do you remember cat clicker? Do you remember being seen on Andy's face as the project requirements changed again and again and again? I remember it very well. Poor Andy. Well, anyway, our final version has two main areas. It's going to have a list of cats and a cat detail area where you can click on the currently selected cat. Well, as it turns out, the last few lessons have gotten us ready to build Cat Clicker, and this time we'll build it right. Now, I'll tell you from personal experience, even though I've built a lot of applications and structures with wood too, for that matter, one thing I hate doing is planning. But every time I don't plan things out, they end up taking much more time. And by the end, I wish I'd spent the extra time to plan. So let's take some time and plan this out. Let's go over the problem again. We want to build an application with a list of cats, and when you click on cat in the list, they will display in the cat viewing area here. And what's more, the number for the number of clicks should always reflect the number of the current cat. We're going to go through this right now and figure out what should belong to the model, the view or views, and the octopus. First, let's identify the model and the view portions. Of the following things, choose whether they belong in the model or the view. The clickable list of cats here, the current cat display, and the array of cat objects which is driving all of this.
So what's the question again? So it's asking you those things are belong to the model or the view. So a clickable list of the cats is something user can see, so it's going to be in the view. The current cat display is also something user can see, so it's going to be in the view. And the array of cat objects, that is just data, so it's going to be in the model, right? So it's a view, and a model.
The array of cat objects will definitely be in the model, since it is the data that represents our cats. The clickable list of cats and the current cat display are both part of the view. They are things that the user sees and interacts with. Now let's review the model and view in a bit more detail. The model is going to be super simple. It's just our data, an array of cat objects with properties for name, click count, and image URL. Nothing new here. Now the view, well, actually, if we want to, we can split this up into two views. First, we have the list of cats, and second, we have the cat viewing area. Both of these views will be pretty simple. They'll just have render functions that redraw the respective areas. And they'll have click handlers registered for the various cats up here and for the image down here. Now, why am I splitting them up into two views? Well, here's a good way to think about this. Think about how separate they are functionally. Not with regard to action, but with regard to what gets rendered. The list renders a list of cats. When does this re-render? Well, right now, it only renders one time at the start of the application. This other part renders cat details, and it gets re-rendered every single time you click on the cat. Now, they're both separate visually and in terms of when they get rendered. Separation does make some sense here. Now, if you wanted to make them one view, that would work just fine, but it's generally a good idea to separate out functionality into smaller chunks whenever it's possible. Now, where is Larry, our octopus? How do our model and our view connect to each other? Well, let's think about what things happen in our app, and maybe we can sort this out. So first of all, the app loads up. We start with a blank screen. First, the list gets created. Then the list view populates with cats. Larry the octopus does both of these things. Now, not for rendering it on the screen. That's the job of this particular view. But our octopus is what tells this view to render itself in the first place. In other words, the octopus gets things going. Then the octopus changes the current cat in our model. Current cat gets set to this first cat. When that happens, the octopus says, hey, go ahead and render this view here. And then the current cat view gets rendered. Now again, the rendering of this view here is not the responsibility of Larry, but Larry the octopus does tell that view when to render. So now the octopus has gotten our model started, gotten our views started, and everything has gotten rendered. Now let's talk about the case where the user clicks on a cat. Well, the octopus is keeping track of where you click. So if you click on this cat here, the octopus will run a method which increases this counter, first in the model, and then in the view. Now if the user clicks on a cat up here, let's say on this second one here, then the octopus does the following things. First, it changes the model. The current cat is now being set to her. And then it tells the view over here to re-render itself. So to recount, when the app loads up, first Larry initializes the model. Now in this case, we just have simple data, so that doesn't mean very much. Then Larry tells all of the views to render themselves. And finally, our octopus says, whenever you click on any of these things, do this particular or that particular piece of functionality, and then tell the respective views that have changed to re-render themselves. Now let's take Andy's spaghetti code and identify what parts of it belong where. Because as it turns out, you can do this. If you separate functionality into these three buckets, model, view, and octopus, you can take spaghetti code and refactor it to be organized and extensible. You can find the repository with Andy's actual code in the instructor notes. Now the first thing I do before refactoring is I run the app itself. I play around with it and figure out what the functionality is, and that will help me understand the code later on. It looks like you can click any of these buttons here and you'll get a different cat. You can also click the image of any of the cats to increment the number for the cat. And go ahead and hop into Andy's actual code and see if you can figure out how Andy is displaying the different cats.
All right, let's see his code. So again, he has a similar code like mine. So it has a 5 cat together, and he's using the jQuery. Let's take a look of his app.js. So what the question again is asking, how is Andy displaying the cat when you click each of the buttons on the top? Yeah. So it's next one like a bind button to cat. Let's look at the functions here. Firstly, he selected something with a class equal to cat, something with a let's select all the buttons, and this one is hide all cats, and this one is bind button to cats, and the bind counter to cat, and let's have two for loops, and hide all cats, and cats show here. So, right. So those are just functions. They're not gonna run by themselves. And firstly, the code is running is like firstly it has a variable cats. Basically for all the cats with a class equal to cat. And also he select all the buttons he has. Then the code he run is this one. For loop, it's for all the buttons. Like for where I start from 1 and I is smaller than buttons are length. Like it's basically just a loop from all the buttons. And bind the button to cat function. This one bind the button to cat. This one is basically is an event listener and a click event listener to it. And whenever they click something, it's using the jQuery syntax. So if you don't understand it, it's okay. Just treat it as an event listener. So whenever the like it's add event listener to the cat, it's saying when you click a cat here, I'm going to run a function hide all cats and then show one of the cats. So the hide all cats is also a function he has here. Hide all cats. Basically, just going to hide all the cats he has. And every time when after all the cats are hide, and then it's going to show one of the cats. It depends on the which button it is clicked on. All right. And then it's going to next thing is bind counter to cat. It's about counter, so it's nothing to do with this question here. So how is Andy displaying the cat when you click each of the button on the top? First one is replace DOM element in a single view with the info for each click cat. Keep a separate view for each cat and show and hide them. Yeah, as we said, like every time when you click a button, it's going to hide all the cats and show one of them. So it's basically show and hiding. So it's basically the second one.
The answer is that he's keeping a separate view for each cat and showing and hiding them. Let's take a look at Andy's HTML. It looks like he hard-coded all 5 buttons and all 5 cats down here. Now, if we had asked him for 15 cats, this would be a very long file. The other thing to notice is that he doesn't have a single area to show the cat. Every cat has its own view, if you will. And as I mentioned before, if something bad happened and somehow 2 of these were shown at the same time, that could break the way the application looks.
Right, so the issue he mentioned is also happening in our own code, right? Like our code, like right now, I only have 5 cats, and I already have a list of five cats, 5 buttons, or 5 this item here. Imagine we have like a hundred cats here. I have to create this item 100 times, and same thing for the cat data. If we have 1,000 cats, 100 cats, we're going to create 100 clicks here and 100 cases here, and same thing like it's going to have 100 show functions here. So it's kind of like not not scalable, and also the code I mixed together. Like I have no idea which one is model and which one is view and which one is octobus. So we're gonna separate them later. Right? Let's keep watching the video.
Next, we'll take a look at the JavaScript. In Andy's JavaScript file, one of the first things we see is the hide all cats function. As you can see, he's going over all of the cats and hiding every single one of them. The first 2 things we see are var cats and var buttons. These are variables, and in them is stored a jQuery collection of the cats class objects and the buttons class objects. And the next thing we see is the hide all cats function. What Andy is doing here is looping over all of the cats and hiding each one of them. Now, this isn't the best way to do things. If you have many views for a single area instead of one, A bug in your code could easily make multiple cats show up simultaneously, breaking the layout. And as we saw before in our HTML, each cat does have its own view. So that's kind of bad news. But in terms of classifying what these things are, they all seem view-like. This represents the cat views, this represents the buttons, and then this function here is the function that hides all of the cats, effectively changing the rendering of the page. So, all three of these things seem very view-like. If we continue looking at the file, we'll find two more functions, bind button to cat and bind counter to cat. And you'll also see that these two functions get called here in for loops, where we go over all of the buttons and all of the cats, and run this for the buttons and this for each of the cats. So what do these two functions effectively do? They effectively add event handlers to our buttons and to our cat images. In this one, when you click on a button, it hides all the cats using our function, and it grabs the cat with the ID of cat1 or cat2 and shows it. In bind counter to cat, it's saying whenever you click on the cat, do the following. Get the click count from the DOM, parse it into a number, and then re-update the DOM with the new counter. So now, where do you think Andy's model effectively lives? Where is he storing his data?
We'll store those data. Let's see. It's just as what's the question again? Where the store the where the Andy's model of div? In a variable, right? It's basically store things in the variable. Like they have a variable count and to store the stuff. It's the same thing as ours. Like we have a Andy click, a Bob click, or a Charlie click. They just store things in the variable. Right? That's submit the answer. Oh, wrong. Not wrong. Let's see. In the DOM. I don't know what they're talking about here. In the DOM, that means like maybe he's talking about like he didn't separate things together, and his variable is mixed with a render function. So this is why he thinks he's storing those things in the DOM. Right, let's keep watching.
The answer, it turns out, is in the DOM. Like I mentioned before, in bind counter to cat, it gets the current number from the DOM. It finds the counter object, grabs the text out, turns it into a number, adds 1, and then updates the DOM with a new number. So where is that data coming from again? It's coming from the DOM element. Now the number of clicks shouldn't be stored in the view or octopus areas. Remember that the model is for data, and the number of clicks belongs in the model. But Andy is storing it in the view, and that's a problem. So we've established that Andy is storing his data in the DOM, and that's one of the reasons that his code has become kind of spaghettified.
Yeah, like I said, he just mixes things together. He doesn't have a render function. Every time when you click something, it just gets a current counter and adding one. Get the current counter from the DOM and adding one to it and replace it to the old place. Our code is doing a little bit better than his. We are storing things in the variable, and every time we just increase that variable and create re-render that in the DOM. But it's still not optimized way, optimal way to store the stuff. We're gonna separate our code into the model and the view later. So let's keep watching.
I'd like to take a moment to defend Andy.
Thank you, Ben.
Sure. In his defense, it's really easy to justify storing your model in your view because it's so easy to do. For version 1 of Cat Clicker, he didn't set up anything special to store his data. He just asked for the data out of the view, updated it, and put it right back. But as we can see, that did not scale very well when his project got much bigger. The biggest issue with Andy's code is that he stored his data in the DOM. Or, more generally, he didn't separate his view and his model with an octopus. In fact, in his code, the model and the view were the exact same thing. And that's what got him into so much trouble.
Alright, so we know what the trouble is right now, and I think we're gonna rebuild it.
I think it's about time we try building Cat Clicker again. but this time we have better organizational skills. You'll be doing the same project we ended with before. The application shows a list of cats that when you click on one of them, it updates the cat detail area with the clicked cat's details. Now the primary thing you need to remember is to separate out the view entirely from the model. Use an octopus for communication between the two. Never do it directly. Personally, I would build it with two views, one for the cat list and the other for the cat detail view, each with their own render methods. And remember to never have the model and view talk directly to each other. That's very, very important. Once you're done, I'll show you my model view octopus implementation. Here's the spec sheet for Cat Clicker Premium. Go forth and build it.
So it's time to re-render all files. I think it's a sim requirement. It's a view and the iterator when the cat name is clicked in the list, the cat display is the same. Basically, it's the same requirement. All right, let's change our code here. What I have here before is like we just store things into a variable, right? Like let's mix things together. Right now we're gonna separate things into two parts, into three parts, into the render, into the model, and the octopus. Let's separate things. Yeah, so first we're gonna have things. We're gonna have things in the model, which are the data, right? Which are the data here. It's variable cats. We're gonna have all our cats in this array of cats. So those are the places we store our data. That's our only data we have here. So we're gonna have a cat as different object. A cat will have a name, and it also has a name. It has a picture. It has an image. Right? It has an image, and it also has a number of clicks. Right? It has clicks. Those are three things a cat has. So we're gonna have a list of those objects and display in different cats. All right. The first one, the cat has a name with Andy, and image is Andy.jpg, and the clicks is equal to just start from 0. That's the first cat. Let's copy that. We'll come on, separate them. Let's go second cat. The second cat is his name is Bob, and is using the picture of Bob.jpg. And again, the clicks start from 0. And comma sort item in the array is we're creating an array of objects. The third one is Charlie, and it's using the image Charlie.jpg, and it creates a comma. Fourth one, this is David, and the image source is David.jpg, and clicks 0. And the last one is Effie. Image is Effie.jpeg. Right? It's a file name, right? So we have a list of cats. It's the data we stored in our model, right? Right now we can start worrying about like how can we use those models? How can I use that to replace our current view I have here? Firstly, let's have another thing about rendering the cats, right? So I have the octopus and the render and the views. So let's open the files we created, which is this one here, right? So this name here right now is static. We just create them one by one. This item, Andy, this item, Bob, this item, Charlie, this item, David, this item, Effie. We actually can grab the data we have in our model and then create this list. Right? We already have a list of cats, so I just grab all the items I have in my list and generate. No matter how many items I have here, I just generate a list inside here. Right? Let's remove all these items here I have here right now. We're going to dynamically generate those ones. So in the view function, we're gonna have an initial function, initial the list function. This function initial list, which is going to generate the. It's gonna take the array of cats. It's gonna take a cats list and generate these items depends on the array I give it. So that what it does is going to be function, and it's going to create this item. So for we're gonna have a list here for loop for a variable I start from 0. Or we can using let here. This is ES6 syntax, and I smaller than cats dozens. I plus plus. I loop through the whole list. Now what it does is basically first it's going to create a cat. This item. Let's create this item. Is equal to. Let's just use a constant. I'm not going to change the constant of it. Constant of this item is equal to document the. Right now we're dealing with a view, so we're just dealing with a DOM. Document the create element. We're gonna create an element here. Create I item. Right? We'll create this item, and then this item going to have the whatever. Going to have a class. Right? Those are these items. Just leave one as an example. We're going to have a class. Is a group item and a pointer. Let's add that class to it. How do I add a class? Let's Google it. JavsScript and the class. Let's see how to add a class name. Yeah, it has a here class list at the end. Right, class list at the end. We're going to use that. So it's going to be AI the class list. The end. We're going to add the class pointer. I have a table here. Pointer. That's the first class, and list the class list at the end. We're going to add the list group item, adding 2 class item to it, right? And then the content of this list item is going to be text content. It's going to be equal to the cats, the ice item, the name, right? It's going to be equal to the name I have here. I'm going to do a loop. I'm going to become Andy, Bob, Charlie, David, and if it keep changing. And every time when I create this list item, I'm going to add that list item into our list. So it's going to be our list. Then the list will be we're adding that list item. First, let's select that. Actually, I can just let's select that the whole list. Select this whole list. So what we're gonna do is we're gonna give an ID for this list. This is going to be a list we want to touch. So this is a list, and with ID equals to cats. Right, it's ID equal to cats. So we're gonna have the constant cat list is equal to document the query selector. Oops, query selector with ID is equal to cats. Right, this is the list I want, and I want to append that list item on that list. So it's cat list dot append this list item. All right, so every time I have a cat, I just append it to there. So let's take a look. Let's gonna reorient this list. So nothing is showing because I create a function, but I never call this function. Add even this is null. I'm gonna comment out some code here. It's not gonna work. Let's comment this code. Comment out this code. I'm gonna comment them out. All right. Right now I have my initial list function, and I need to run that function. Where I run a function, I can run that in the octverse because that's going to be a place where I connect these two things. So in here I'm gonna call init list, and the passing array. Array is going to be the cats array. So connect them together. Select the model and the view function together. So let's try to reload it. Cat list is not defined. Let's see. Cat list is not defined on line 22. I defined it here, constant cat list. Why do you think it is not defined? Oh, because I have this, I run this function before I call this variable. Let's put the octopus function at last. Put this here. So I create those variables first, then run the octopus function. Right? Let's do it this way. Well, it works right now. See, I got those lists back again. Like but this time it's dynamically generated from our model instead of we created the static, right? So I have the array of cats, and I have the function initial cat list. It's basically a loop function. It's going from the first one until the last one, and then I just give the cat list to it, and it can dynamically add those cats to my list. Also, I can, instead of using for loop here, I can using the new syntax for off loop. The for off loop is from the ES6. Instead of saying let I equal to 0, I smaller than cancel length, we can have for cat of cats list. We're gonna have a constant list item, and here list item the text content is going to just equal to cat.name. Right, just shorter syntax than just for loop. It should be easier for you to write it. Right, so it does the same thing. Cats is not defined. It should be cats. Right, cat of cats. Yeah, it's still working. Just shorter syntax for that. Alright, so right now the list is rendered, and I'm gonna stop right here because it's a lunch time. We're gonna come back after we come back after lunch. We're gonna do the rest of stuff to think about how we gonna render the cats out, detail out. Right? Let's stop right here. Go have lunch.